Now, today we will be studying suspension and colloids. The first we will go to suspension. So, the first question comes, what is suspension? Now, before going to the definition, let me explain you. What is suspension? You have seen the dirty, muddy water, like pond water, you have seen it. Alright, in the pond water, you will see some particles which are settled down. Achha. You have seen the smoke which is coming out from the chimney. You have seen it. Alright, from a factory, the smoke which is coming out from chimney of a factory. Alright, you have seen that is, you take a mixture of chalk and water. You take some chalk and put it into water. Chalk dust, you take it and put it into water. What do you find? You'll find that everything settles down. Like chalk, when you put it into water, you find the chalk particle settles down. The chalk dust settles down. You see the smoke which is coming out of the factories, you will see some fine particles are there. How do we come to know? Like for example, I am saying you, like if you are going to Rourkela, suppose a station or somewhere, you are putting your vehicle. Alright, for 1 hour you put it your vehicle, or for 2 hours you put it your vehicle and do the marketing and come. Alright, you just allow your scooter or your bike to park there in the parking. When you come back, you just take your finger in this way and rub it over the seat. You will see some particles, it's a black particles you can see over the seat or over the handle, and this you can see it. Alright, what is that? They are nothing but the suspended particles. From where it has come? Because Rourkela is very near to the Rourkela steel plant. The Rourkela main township, I am saying, it is very near to the Rourkela steel plant. Alright, and there you see some particle from the chimneys, the smoke which comes out, the particles are also coming out from it. Alright, this smoke contains what particles? Suspended particles, and this settles down. When it comes into the air, the particle settles down. So as you parked your vehicle, so it has got settled down over your vehicle, over the seat, the dust particles. Okay, I said you muddy water. Alright, so that is nothing but known as a suspension. They are called a suspension, or otherwise known as suspended particles. They are said to be as. I hope you understood. There is chalk in water, or the smoke which contains the particles. I told you the examples. Or the ponds, the mud, the dirty water which is there. Dirty means the particles you have seen floating there and all these things. They are known as suspended particles. So hence, what is a suspension then? A suspension is a heterogeneous mixture. These are all heterogeneous mixture. It is not same throughout. In which very fine particles, alright, and the size of the particle, remember it, 10 to the power minus 7 meter, the size of the particle in case of suspension, or more it can be. Alright, it's a heterogeneous mixture in which very fine particles of the size 10 to the power minus 7 meter or more of solid are dispersed in any particular medium. Alright, like smoke contains the dust particles. Alright, the water contains the chalk dust. Alright, the muddy water contains the mud, clay and all those things which is there. So in this way, that is called a suspension. Alright, I hope you understood the definition. It is a heterogeneous mixture in which the size of the particle is 10 to the power minus 7 meter or more, and it is being dispersed in a particular medium. Alright, in a particular solvent. Fine. Now it is heterogeneous nature, already I said you. The particle size, it is in front of you, 10 to the power minus 7 meter or even larger than that, the particle can be. Alright, and it settles down. It settles down, sediments. For example, you take some muddy water, alright, in a glass, a clean glass you take it, you may take some muddy water. You just don't disturb that water for some time. You will see that the mud or the clay settles down at the bottom. What is that? That is nothing but known as suspended particles. That is a sediment, suspended particles. So always suspended particle settles down. For that reason I said that when you are parking a vehicle in Rourkela, you will see that the suspended particles which are present in the smoke, it settles down. It settles down on your seat, on the vehicle, on your scooty, or on your what you can say seat of your bike. It settles down. So it settles always. It sediments. Got it? So they are very fine particles which remain in the suspension. They settle down. Clear? And it can be separated by the help of filtration. Definitely. For example, chalk and water. How you separate it? You filter it. You will be getting it chalk separately and water separately. For example, muddy water. Filter it. You will be getting mud and clay separately from the water. So you can separate it by filtration. Got it? Now, you understood what is suspension? Got it. Now, basically, here we will see there are three kinds of what you can substances are there. One is a true solution. One is a true solution. Now, what is true solution? For example, a solution of salt in water, a sugar in water, that's a true solution. Another is your colloidal solution. Second, colloidal solution, I am coming to that. And the third is your suspension. Alright, third is your suspension, we can say that. Clear? I will come to the difference. But first let me tell you colloids. What are colloids? A colloid is a homogeneously looking. It is homogeneously looking, but it's not homogeneous. It's a heterogeneous mixture. Got it? It is also called as commonly known as soul, and the size of the particle is 1 nanometer. Got it? Or 1 nanometer to 1000 nanometer. Got it? 1000 nanometers. The size of the particle varies. So 1 nanometer means 10 to the power minus 9 meter. We can say that. So the particle size varies from 1 nanometer to 1000 nanometer. It is said to be as, got it? So particle sizes or 10 to the power minus 9 meter. It is generally known as soul. In short, we call it as soul. We can say that. Colloidal solution. It is known as soul. Colloids. So colloidal solution actually it is a continuous medium in which we are having a dispersed phase and dispersion medium. Got it? We are having a dispersed phase and dispersion medium. Listen carefully what I am saying. Dispersed phase. The what you can say, dispersion medium is nothing but the solvent, and dispersed phase is nothing but known as a solute, because solution is made up of what? Solvent and solute. So generally the dispersion medium is called as a solvent and the dispersed phase is known as the solute. Remember it. The particles of the dispersed phase are present in the dispersion medium. So let me give you an example. Colloids are nothing but milk is a colloid. Then your gum is a colloid. Gum which you are putting with a paste. Alright, that's a colloid. Then blood is a colloidal solution, we can say that. The toothpaste is a colloidal solution. Jelly is a colloidal solution. Jams or jellies, they are the colloids, we can say that. Alright, then starch is a colloidal solution. Fog or the mist is a colloidal solution, we can say that. Clear? In the fog and the mist, what is that? The dust particles is your dispersed phase. Alright, and the dispersion medium is your nothing but known as the water. Clear? Similarly, in blood, the what you can say, the formed elements, RBCs, WBCs, they are the what you can say formed elements. It is known as, they are the dispersed phase, and the plasma, that is a liquid one. It is said to be as a dispersion medium. In this way, we are having dispersed phase and dispersion medium. So we are having fog, we are having nothing but is your blood, we are having that is your jams, jellies, we are having that is milk, there that is then gum. The starch solution, they are all coming under colloidal solution, which is made up of two dispersed phase and the dispersion medium. Fine. Now there are what you can say different types of colloids we are having. We are having liquid colloids, we are having liquid gas colloids. Alright, liquid gas colloid is known as liquid aerosol. Liquid gas is your fog or the spray, this liquid spray. Now you are using the hand sanitizer. Alright, that is the liquid sprays. They are coming under the liquid gas colloids. We are having solid gas colloids, we are having liquid colloids, and these are different types of colloids are there. Alright, we are having it. Now, if you see the properties of the colloid, just like your suspension, they are heterogeneous in nature. The particle size already I have said you. They the colloidal solution generally pass through ordinary filter paper, but it cannot pass through ultra filters. A special kind of filter paper that is called as ultra filter. Alright, and they can be separated by ultra filtration only. Now they are unstable. They are not stable, they are unstable. That is, unless and until it is stabilized, they are not stable in nature. They show the Brownian movement. Brownian is nothing but the zigzag motion. The zigzag movement is said to be as the Brownian movement. The rapid zigzag movement means you just take a colloidal solution and observe it through a microscope. You will find it out. You cannot see it with naked eyes. Understood? By microscope you have to observe it. When you observe it through a microscope, you will find the particles, that the dispersed phase, the particles are striking one another. Alright, continuously. Got it? Continuously in this way manner it's striking. This particle strike this in this way. So this is a continuous random motion, zigzag motion, that is known as the Brownian motion. Why it is called Brownian? Because Robert Brown, an English biologist, he find it out for the first time and he called it by his name, that is Brownian motion. Next is it shows Tyndall effect. What is mean by Tyndall effect? Tyndall effect means you take a colloidal solution. Suppose you have taken a beaker, you take some colloidal solution here and you pass a strong beam of light. You will see the light gets scattered in the form of cone. What is that known as? Tyndall cone. This is known as Tyndall cone, and the effect is known as Tyndall effect. This is called as. Alright, when you pass a strong beam of light through a colloidal solution, the light gets scattered. It does not pass through. Through a true solution, the light will pass through. Suppose you take a sugar solution and the salt solution. If you take a strong beam of light, strong beam does not mean a torch light. No. Strong beam of light, mercury light or something light. We can say that. Clear? So you pass it through it. You will find the light, in case of colloidal solution, it gets scattered. See here in the figure. It gets scattered in this way. It gets dispersed in the form of cone. That is called as the Tyndall cone. And the effect is known as Tyndall effect. That's it, yes. If you take a true solution like sugar or salt solution, the light will simply pass through because true solution is transparent. and colloidal solution is translucent. Translucent means light partially passes through, and suspension are opaque. The light does not pass at all. It does not pass at all. We can say that. Clear? We can say in this way. Understood what is Tyndall effect? The light gets scattered. We can say that light gets scattered when you are passing the strong beam of light through colloidal solution. Then it also shows the phenomenon of electrophoresis. Now electrophoresis means when you pass electric charge through colloidal solution, then what you can say is that the particles, the colloidal particles which are having the positive or the negative charge, they are pulled towards the two different electrodes. They are being pulled towards. See, we are having two electrodes are there. In a battery, two electrodes are there. One is a cathode, another is the anode. Cathode is negatively charged and anode is what you can say positively charged. So positively charged particles will pull towards the negative electrode, and the negatively charged particles will be pulled towards the positive electrode, because opposite charges attracts, like charges repels. Remember it, what I said, the positive, let us say this is positive and this is negative. Alright, the blue one is positive and this is negative. So if it is positive charge, the negatively charged particles will go here. If this is negatively charged, the positively charged particles will go here, in this way. So in case of colloidal solution, what you do is that as it constitutes colloidal solution, sometimes it not all colloids, some certain colloids, they constitutes of charges, and when you pass electric current through it, it dissociates into its charges. Got it? That is called as electrophoresis. That is the movement of the colloidal particles under the influence of electric field is known as electrophoresis. We can say that. Next is colloidal, where it is being used, colloidal solution. It is used in medicines. Alright, like many medicines are used as colloids. It is used in our food. As I said you, the jams, the jellies, they are the food. We can say that. The milk is a colloid which is being used as a food. Starch, it is protein. They are also used as a food. We can say that. Alright, colloidal gold, colloidal silver, they are also being used in the form of medicines. We are using it. Alright, rubber, it is a natural colloid. We can say the latex, from which you are making rubber. There is a natural colloids. We can say that. The formation of deltas, it is nothing but due to colloidal solution, we can say. So all these are known as the uses of colloids. I hope you understood. Thank you.